Hello and welcome back to the increasingly inaccurately named More Fun Making It. My name is Lee and today I'll be sharing with you my first experience repairing a broken ZX Spectrum. A properly broken one. Not just, oh dear, a rubber foot fell off. Oh no, an actual broken one. Broken as in some of the magic smoke has been let out of this poor old thing. I bought this 48K issue 2 Speccy as a project knowing it would need to be repaired. This seems to be a growing pastime these days and is reflected in the price faulty Spectrums currently sell for. Since buying this one at close to £40, I've seen numerous Speccies in good working order sell for less. But buying one that's already working means you only get half the fun, so I suppose the price is a fair reflection of its entertainment value. As usual, I should point out that I am, at best, an enthusiastic amateur, and that these videos should not be seen as tutorials, but more as part of a journey I can share with you. If you learn anything, well, that's on you. I can't be held responsible for your feelings of incredible personal growth. This is my first issue 2 Spectrum and is likely the same as my first Spectrum back in 1982, so this is probably my second issue 2. Okay. The ULA is a 5C112E-3, which was among the second revisions of this chip. This fixed some of the issues found in the earlier 5C102E, but probably for giggles left some that required the inclusion of the spider mod you can see squatting over the CPU. The ULA we have here runs fairly hot compared to later versions, and it's recommended to desocket it and solder it directly to the motherboard with a heatsink stuck on top. I'm reluctant to take those steps. Removing a 40-pin socket from a fragile motherboard of this age is no easy task and carries some risk of damage. If this was an irreplaceable part, I would be more inclined to protect it by going through these steps. But there are now modern drop-in replacements for the ULA. This chip has lasted this long being baked by the voltage regulator dumping heat into the enclosed case, and I'll be doing something to remedy that shortly. So heat shouldn't be as big a problem. Maybe this will mean the ULA could chug along for another 40 years, who knows. The state of this voltage regulator is of concern. I shared some pictures of this on my Twitter feed along with the theory that it was soldered in place by a plumber with a hammer, probably on a Monday. There's far too much solder on the top side, probably hiding a multitude of sins. And if we look on the other side, not enough here. This will be the first thing to replace. Before we get into that, a quick run through some of the tools I'm using. Some lovely Rosencore 6040 leaded solder. Do your own research on the pros and cons of molten heavy metal. Tweezers, these are incredibly useful. Different sized and shaped tips make them even more versatile, and you can buy these in a set for not very much money. A solder sucker, it doesn't have to be a fancy one like this engineer Japanese made one. In fact, I still use my old cheapo I've had for years for more delicate solder slurping jobs. The engineer one is very powerful and I've seen it suck pads right off of old circuit boards. An essential, solder wick. Apply flux to cheaper wick to make it work similarly to more expensive wick. That's today's cheapskate tip out of the way. Something it's worth spending a little extra on is flux. This Topnick SMD no clean flux is amazing. It comes with a brush in the cap to make application simple and efficient. That being said, a flux pen like this will do just as good a job, and I still use this one on less delicate joints. Just be sure to clean the flux off after. An anti-static wristband, preferably attached to ground. Some flush cutters. These are another essential. You can work with traditional side cutters as found in an electrician's back pocket, but for precision work you really need something with a little more finesse. Isopropyl alcohol for cleaning up flux. This bottle is the 99% proof stuff. And my little silicone mat. This is to save my workbench top from burns and also to stop small things sliding around. Although I seem to have painted the back of this one in Amiga beige. Let's get this 7805 regulator replaced. Before I began this, I ran through all the initial checks you should perform on a suspected broken Spectrum before risking turning it on and causing more damage. These checks can be found on the excellent Joelspur Column YouTube channel, which I highly recommend you check out if you need to troubleshoot a Spectrum. The The result of these tests showed there was a problem within the power delivery part of the circuit and pointed to either TR4 or TR5 transistors being faulty. It's a very common point of failure, especially on issue 2 boards that haven't had the extra recommended DC components fitted. We'll be getting into that a bit later. I'm fitting a Traco switching voltage regulator instead of the 7805. There's some debate over this, which revolves around keeping the Spectrum at its original spec, but this is a compromise I'm willing to make. The heat generated by this 7805 used to be enough to keep one side of my old Spectrum hot. I still remember feeling the heat under my right hand during extended manic minor sessions. And that heat will steadily dry out the electrolytic capacitors and age the keyboard membrane. The Traco also runs a lot more efficiently, which is good for the planet and my pocket. The two transistors, TR4 and TR5, are, I believe, responsible for generating the 12-volt rail. Again, not an expert. I do know for sure that if one of these is faulty, it's very much worth replacing the other one too, due to the likely chance it was damaged at the same time. The Jolsberg column tests show a likely fault with one of these, but the surest way to know is to remove it and test it out of circuit. The simplest way I've found to remove a component with more than two legs nice and close together is to flood the 3 pins with solder, which allows you to heat all 3 at the same time, then grab the part with some tweezers and pull it out. Once the transistor is out, either solder braid or a solder sucker to clear the holes, sometimes both. And what do you know? This transistor has magically transformed into a pair of resistors. All of the parts I'm using were bought from retrolium.co.uk, who gave me excellent and super speedy service. Here's a couple of new transistors, a ZTX651 in TR4 and a ZTX751 in TR5. Inserted paying attention to the silkscreen for orientation. Gratuitous close-up shot. Watch the solder freeze. Lovely. I did snip that top lead shorter once I had the microscope out of the way. I'm now confident the power issues are fixed, but before I test I'll do a composite mod to make it easier to get a picture. I like to leave the mod reversible just in case a future owner wants to put things back to stock. That sleeving on the resistor might not be considered stock now. I've mangled it a little. Next I desolder the 5-volt and video signal connections to the modulator and fold the leads up over the edge of the metal case. These are no longer connected to anything but the modulator itself, and once the case lid is replaced are in no danger of coming loose. A 100 nanofarad capacitor, which was supplied with the recap kit along with a couple of other extra parts we'll see shortly, will be the new connection between the RCA jack and the motherboard video signal. And with the composite mod mostly complete, we'll come back and finish it a little bit later. It's time to test. Oh. The screen is very blue and quite flickery, but the system does run. We can work with this. With my Dandinator cartridge in diagnostic mode, there's a fault indicated in 2 of the upper RAM ICs. I can ignore those for now, and while replacement memory chips are winging their way to me in the post, I decided to work on the display issue. The first thing I needed to know, is the ULA faulty? If it is, then it'll be one of the most expensive parts of the machine to replace. The RAM ICs, for instance, are just a few pounds delivered. A replacement ULA would be in the ballpark of the price I paid for the whole system. This is easy to test when you have another similar vintage speccey though, and it turns out the ULA is fine. Just in case there's something strange going on with the faulty RAM, I decided to remove it. The Spectrum will function fine in 16K mode until I get it replaced. The next thing to replace are the two transistors near the modulator. These are an option to be replaced when doing the composite mod, especially if the resulting picture is dark on a modern screen. I'm replacing these with BC549 transistors, which are a direct replacement but need to be reversed from the original orientation as indicated on the silk screen. The picture did not improve, which is not really surprising. The next thing to replace is all of the capacitors. It's an old computer with date codes of 1982 and 83, and given the heat generated by an issue 2 Spectrum with an early ULA, it's likely most of the capacitors have dried out to some extent. But will this fix the video issue? Well, after replacing the first capacitor and testing, it seemed the picture was now acceptable. So I fixed it, right? Well, no, not exactly. As I replace the capacitors one at a time, I test to make sure everything is still working. Saves tracking down a bad capacitor or a mistake. And after replacing the very next capacitor, the video returned to the same bad output I was seeing before. So, not the caps, or not those ones. A side quest here. The DC mod that brings these issue 2 boards up to something more reliable is also included as part of the capacitor replacement kit from Retrolium. I've done this mod on an issue 3B board before, and on those it was a lot more complicated with more components. On the issue 2 it just needs an extra capacitor placed here and one of the resistors changed. The instructions are helpfully included with the capacitor kit. I have incredibly fond memories of my Spectrum. It wasn't my first computer. That honour goes to the dainty ZX81, a computer that was at one point rumoured to be so cheap they would eventually turn up in boxes of breakfast cereal. Much as I loved my ZX81, it was a brief and fairly frustrating relationship. Soon ousted by the Wonderkin with the colourful stripes and the keys you could press down. Of all the memories I hold of that part of my life, the time I spent with my Spectrum peering into a grainy TV from just a few inches away, hands resting lightly on the rubber keys, eyes wide in wonder, are the memories I have with the most colour and warmth. It's also the first computer repair I ever made in my life. My keyboard stopped working, which meant a trip to the local computer store to purchase a new membrane. Another vivid memory peering into the guts of my computer which I had never to that point opened up. And with all the capacitors replaced, has the video issue been resolved? I think you can tell by my anguished groan it has not. I'm poking a finger at each of the chips to see if anything is getting hot, also to see if pressure on the chips changes anything. No heat and no change. In the end, the problem turned out to be the adjustable resistors that needed tweaking. My apologies for the experts watching that have been screaming the answer at the screen. I'd been avoiding touching these as my understanding was that this was something that required an oscilloscope to do well, and I'd recently sold my very old analog one that would have been perfect for this job. After looking up alternative solutions, I found a website link in the description that described how you could achieve the same or similar results using a multimeter. I did this, and as soon as the last tiny tweak was made, the picture sprang into perfect colour with no interference. It's actually a nicer picture than my issue 3B. The memory IC soon arrived from the lovely Retrolium people, and keen to get the repair completed, I set about installing it. At first I was a little confused by the lack of a cutout or mark on the chip denoting the direction this should be installed, but in the end I took a punt, which turned out to be right. I know it's popular to install sockets for replacement RAM. I didn't find it too difficult to remove the faulty chips, and I think sockets are a little ugly on the board, plus they're another potential failure point. So I decided to solder the RAM directly to the board. Ready for a close-up? And does this new RAM actually work? Is it even the right way round? Time for the Dandanator diagnostic. The colour is still off here as I still needed to tweak the resistor settings as I filmed this part. With all the inside gubbins now repaired, it's time to put it back together and make it look pretty. For cleaning, there are lots of options to choose from. For really grubby cases, I would usually just dunk it in a big tub of warm, soapy water and get scrubbing. This one is fairly clean already, so I'll just give it a going over with IPA. For this, I'm using 70% proof. The extra water in it stops it from evaporating so quickly and is better at removing the dirt from the surface. The Zombie Flesh keyboard is also pretty clean and only needs a mild scrub. Luckily, the keyboard membrane is still in excellent condition. This must have been replaced at some point in its life, as an original would have poured from the case like a desiccated Dead Sea Scroll. It's a little grubby, so I gently clean it. I also removed a few millimeters from the ends of the connectors off camera. You can see the metal keyboard overlay wobbling under my hands here. When I first got this Spectrum, I discovered this was stuck down with blue tack. Probably not the ideal method. The metal shield is also bent from being pulled up when someone has tried to remove it in the past, which can be quite tricky to put right. The more you try to unbend these, the more they tend to kink and warp. Before I attempt the unbending, I need to remove the old glue. Mostly this is just hard work and scrubbing, but I thought I'd try something designed to remove nail polish. These wipes don't contain any acetone, as you would normally expect to find in nail polish remover, which is a good thing. I wouldn't want that getting onto parts that might get damaged. The wipes do a great job removing the glue. I need to keep a tub of these in my toolbox. At this point, I'd already taken the worst of the bends out off camera, but I will show how I did this and try to take the last kinks out. A vise is a very handy thing to have. This one is called a nippy. It uses a cam action to nip the piece you are gripping. It can exert a lot of pressure, so with a couple of pieces of paper in the jaws to protect the surface, it's ideal to straighten the faceplate. You won't get every part of the bend out, but it certainly gets close. Double-sided tape, another toolbox essential. The last job is the white ZX Spectrum logo needs attention. It's not too difficult to remove the old paint with some IPA and a quick wipe over. I was confident in my brush skills that I'd be able to hand paint this with a tiny brush and lots of patience. Well, my patience soon ran out after a few attempts. I couldn't get a finish I was happy with, so I moved on to a different method. I'd seen Real Jam Hamster off of Twitter do this with dense foam, but I didn't have any of this to hand, and the attempts I made with less than dense foam were not satisfactory. In the end, I discovered that a pencil eraser dabbed carefully did an excellent job. It took a few coats, but the final result was pretty good. And to finish it off, another tip from Real Jam Hamster. Renaissance wax gives an amazing finish to these old computers. It looks especially good on textured black plastics like this and the Atari 2600, and will help protect the surface from being handled with greasy paws. Speaking of the 2600, in the next episode I'll be repairing and restoring at least 2 of these. So you have that to look forward to. Thank you for watching. I hope you enjoyed this episode, and I'll see you next time. Bye!